Example, we want to solve a set of general kind of linear programming approach. So suppose we have an objective function which is the summation of some x, let's say sum over I of ci multiplied by xi, subject to summation of ami multiplied by xi greater than or equal to bm, and we have m constraints and I decision variables. Okay, so BM, I, AMI, and CI are known parameters to the model. So in order to solve that, I want to give you an example, a simple one actually, with two decision variables like x1 and x2, and also the coefficients of x are specified here as c, 7 and 12. These are the C1 and C2, Ci here. And also A is a matrix specified here. And here we are writing down each row of this multiplication. So 3x1 plus 4x2 greater than 4. This is one row of it. And the other row will be 2x1, 5x2 bigger than 2. Okay, so since we want to write it down as a general model, and if we increase the number of decision variables or the number of constraints, that should be also working. So we decided to do it in a abstract kind of modeling. Okay, so in order to do that, after we define the model as an abstract model, we need to specify the input data. So in order to do that, we have to create another file with the dat extension and then specify the sets and also the parameters of the model and so on. Okay, so here you can see that C, since it's defined over 1 and 2, you can see here 1 and 2, the value is 7 and 12. And also the other parameter like b is defined over set m, m1 and 2. You see here that 1 and 2 is here and 4 and 2 is here. Okay, and also finally a is described here. Okay, so let's have a look at the code together. So it's here, let me show you. Okay, so first of all, I imported the required packages. Okay, since we don't need any kind of plotting, I removed the matplotlib importing, and also I don't think I need the numpy, so let's leave it right there. That's fine. If we need it, we can use it. Okay, so we have two imports, and then I have defined the abstract model. Set n and set m. Set n is telling us how many decision variables do we have, how many x do we have. Okay, and set m is telling us how many constraints do we have. C, A, B are the coefficients of the model. Okay, C is defined over set n, A is defined over m and n, and B is defined over m, and decision variable is defined over set n. Okay, and we are assuming that these are non-negative reals, positive ones. Okay, and we have some constraints that needs to be created. In order to do that, we need to define model con, or I just named it con. You could name it something else, that's fine. Constraint. This constraint is defined over model m. It means for every constraint we have some rules. Okay, so how should we define that? This is the way we define it. Define con rule, model and m, and return summation of this expression, model a, m and I multiplied by xi for every I in model n bigger than or equal to model b m. Okay, so we are exactly repeating what we saw here. Okay, so let's have a look at this code again. You see, this is the constraint that we have written here. Okay, so let's continue. The objective function is the summation of ci multiplied by xi for every I in set model n, and the objective function follows this specific rule that we have already defined, so that will follow the rule, and the sense is the minimization. So if we look at the model structure, we see that it's a linear programming one. Then we have to define the solver we are going to use. Okay, and so let's say opt is equal to solver factory glpk. Glpk is a solver that can be used for linear programming, and in order to solve an abstract model, we have to create an instance. Instance will be created using this command. It is equal to model.create instance, using the data file that we have in the same root, and then we will ask Pyomo to solve the model for us. Result will be equal to opt.solve instance. So the model will be created and the data will be fed into the model, and this line will solve the model for us. Let me solve the model and see what is going on. Okay, so after the solve is finished, the results are already in the results. For every I in the instance.n, we will print the value of x. Okay, so how should we define the value of x? We have to print the value of instance.xi, but we have to create a loop to tell Pyomo to print every x that exists in the model. And finally, of is equal to value of instance.of. Okay, so in order to have access to the solved values, we have to use the command value instance dot something that we want to see the value. Okay, so let's run this one as well. So you can see that the x1 is equal to 1.33, x2 is equal to 0, and of is equal to 1.33. Okay, so this is a very general kind of model for solving the optimization problem. So you can see here, if we want to increase the number of decision variables, that can be easily done. If we increase the number of decision variables, then we have to change the number of n. Not only is 1 and 2, then we can have 3, 4, 5, and so on. And that model is a general format for solving any linear programming. Thank you very much.